Hi, this is Mr. Holmberg at Corvallis Middle School, and this video is just about its introduction or a review for the basic use of coordinate pairs on a grid. By the time students are in 5th grade, they most likely have had some sort of experience with this, but they may not have mastered it. And we're going to move kind of quickly through remembering how coordinate pairs work, and we'll be going forward with that in the coming days then. I'm going to show there are all kinds of different materials you can find out there for studying ordered pairs or coordinate pairs. So you see that up here as the title. They say ordered pairs, but they may also be referred to as coordinates or coordinate pairs. There are lots of ways of talking about them. And what they're referring to, of course, here are just these two numbers. These two numbers are like code for how to locate a position on this grid. The grid works much like a map would. In fact, if you go to something like Google Earth, down on the bottom of the screen on the bottom right, usually if you're moving the cursor around Google Earth, you can watch that the entire planet has been graphed on a grid, and every single location anywhere, right down to a few feet, can be pinpoint precision because of a grid system. So students in 5th grade are basically just needing to understand how to locate certain things on a grid, and they don't need to do a lot more complicated than that. As middle school progresses, they'll be doing things like finding distances and drawing shapes and translating, turning those shapes, rotating them, and so forth. Of course, we start out with single quadrant ordered pairs, and that means that all of the distances, just like when you're playing Battleship, are all positive directions, but eventually, before too long, students are going to be understanding that they can move in a positive direction and a positive direction, or they could move positive, negative, or they could move negative, positive, or they could move negative, negative direction. So that's eventually where this goes. Of course, the other thing about coordinate pairs and about this grid system, and why it's just an introduction here on this video, is that the grids don't end, of course, here. If you were to zoom in on any particular grid, it could be divided into further grids of infinite size, or not infinite, but could become smaller and smaller till you're not capable of understanding it anymore. So you can zoom in basically and find more and more grids within grids, and all of those can have very precise positions with decimals and so forth. So why is this important? Well, a whole bunch of linear math has to do with being able to understand that events can be represented on a grid so that you can chart what has happened and you can think about what would happen. And we use this throughout math as students progress. So the good news is at 5th grade it's really pretty simple. And for parents out there, if it's been a while, there are just a few things you need to know. First of all, the coordinate pairs are always going to be two numbers here, and these two numbers in 5th grade are just going to be referring to a positive direction or horizontal direction side to side. Of course, once you move to this sort of grid, it's actually going to be going horizontal both directions. It could go a negative direction or it could go a positive direction. And in 5th grade, it's going to be moving up. So that would be positive, but if you were to go down, that would be negative. It's always this way. It's always the horizontal first, and it's always the vertical second. I like to tell students it's over, before, up. Okay, so a few things to think about here. First of all, students, one common error is that they count squares when they do this, and they're not counting squares, they're supposed to be counting intersections. So for example, if students were trying to find the point T here, I'm going to show this as if they were counting the squares. They would start at 0 and they would count over like this far, and they would count up like this, and they would be looking for an imaginary point that they think is right there, and they decide, well, T is close enough, so I'll call it T. But that is not the way it's supposed to be done. You don't count through the middle of it. While it's easy, of course, to find the distances by sort of counting the squares, what you're actually doing is you're counting just the edges or the intersections along these lines. So if you're trying to find point T here, you would go over, and this would be the second common error, is that students would think, well, if they can go up first. You have to go over first. So it would be 1, 2, 3, 4, just like you're traveling down a road on a street. You've gone over a distance of 4 streets or 4 lines there, and you're going to go up 1, 2, 3, 4, 5, 6, 7. So that means at this point here, if I put it in parentheses for you, if I make my ordered pair, I have gone over 4, and I have gone up, was it 7? Yeah. I've gone up 7, and that's the way that would be represented. So that's really about as complicated as it gets. Students need to make sure they're counting along the lines and looking for an intersection. They are not counting the squares themselves, and they must always go over before up or